So welcome back students. So today I will discuss the fourth chapter and the unit 2 of atomic structures, and this unit 2 contains the geometric representations of the atomic structures. So basically these videos will be really helped you for those students who are actually absent on that day. I have already said about the electronic configurations and the other things. So if the students who are already know how to draw the atomic structures and how to distribute the electrons, so please you can ignore it, but who are not attend that class, you can go through this video, because without this video, without this topic, so your atomic structure will be incomplete. Okay, so before going to the main topic, the electronic configuration in an atom. So what is basically electronic configuration? You have to know this. Okay, so the electronic configurations, basically the distributions of the electrons. Okay, so the distributions of the electrons, basically where the distribution of the distributions of the electrons around the nucleus. Okay, so sorry, so we know that though an atom having the different kind of shells, okay, and the shell having the definite fixed energies, and the path is also fixed, and the number of electrons and that particular orbit should be a fixed number of electrons, and the rules actually basically deals or leads with these things, that is called the Bohr-Berry rules. So Bohr is one scientist and Berry is the another scientist. So according to this scientist Bohr and Berry, this rule actually called the Bohr-Berry rules, or you can say that the Bohr-Berry scheme of electronic configurations. So what is the basic rules of this electronic configuration? So the students, actually we have discussed these things in class 7 also. So that time the electronic configuration is not in detail, but in this class you will deal with the full of concept with the electronic configuration, how to write the electronic configurations. Okay, so see students, suppose that one atom is there. Suppose suppose take one example of this atom, and this part, there is the round, this is the middle part, center part, this is called the nucleus, and this the circular part is called the orbit, or you can say that the shell. So here in this particular case, so see, this part is called nucleus and this part actually orbits or shell, and this is the another orbit. So according to Bohr-Berry rules, the shell that will be your so the first cell that is very close to the nucleus. Suppose to these things very close to the nucleus, this shell, the first cell very close to the nucleus. So Bohr and Berry actually define this path, this orbit actually called the K shell, which are very close to the nucleus. When you goes away from the nucleus, then the shell also increases, as well as the energy is also the increases. So these things we have learned from the Bohr rule also, and Bohr theory, Bohr atomic model also. Basically the Bohr atomic model is the correction of the Rutherford atomic model. Okay, so the first cell that is very close to the nucleus, so define this shell called the K shell. Whenever you have go through the next or another shell, that shell or the second shell actually called the L shell. Again the third shell will come called the M shell, and the fourth shell, that is your N shell. So this K shell basically very close to the nucleus, very nearer to the nucleus, and this whenever this K shell is very close to the nucleus, so define that is a variable number, or you can say that the n values, and this is the n is called the number of shell. Okay, so whenever the number of shell, that is n is equal to 1, that time this shell is called the K shell. Whenever this n is equal to 2, that time it will call the L shell. Whenever the n is equal to 3, that time it will call the M shell. Whenever the n is equal to 4, that time it will call the N shell. That means fourth shell. Sometimes you can represent by K shell, L shell, M shell, or N shell also, and you can also represent by n is equal to 1, 2, 3 or 4, etc. In higher class, these things you will learn from the quantum numbers also. These things I will not discuss in this video. So basically Bohr rule basically deals with the K shell, M shell and L shell, and these rules, these things also. In higher class you learn in the another principle, that is called the above principles. Okay, so very interesting and very important thing that we will learn in higher class. But in your class up to 10, you will learn on this way also only, the K shell, L shell, M shell, N shell, up to class 10. Okay, so the thing is, how many electrons can occupy this n shell, how many electrons can occupy the k shell, how many electrons can occupy the m shell. So which rule actually derived it? The rule is that is called the N2n Square Rule. What is actually 2n square rule? See student, 2n square rule basically deals with the how many or maximum number of electrons can occupy a particular shell. If the shell, in case of k shell, that time n is equal to 1, so how many electron can be occupied by the rules, that is 2n square. So whenever this n is equal to 1, that means k shell, the number of or maximum electron can be occupied, that is 2. How? Because 2n square, 2 into 1 square, that is 1 square means 1, and 2 into 1, that is equal to 2. Again the same thing will come in L shell also. Whenever the L shell will achieve, that time n is equal to 2, that means 2 square means 4, 4 into 2, that is 8. Again as this way m shell will come, m shell will occupy 2 into 3 square, that is 18, and n shell will occupy 32. That means the k shell occupy the maximum number of electron, that is 2, and the L shell will occupy the maximum number electrons 8, and M shell occupy 18, and N shell occupy the 32. This is the maximum number of electrons can occupy one particular shell. This is the first rule. The second rule, the outermost shell. The outermost shell basically student, outermost shell is called the valence shell. Okay, so valence shell means that shell particular participate in valency, or you can say in the bonding purpose. That is actually called the valence shell, or you can say that the outermost shell. Okay, and that particular shell cannot have more than the 8 electrons. How? Suppose that I have a potassiums. So potassiums is total atomic number is 19. So that time if you want to electronic configurations of potassium, that time K shell will occupy 2 electrons, L shell occupy the 8 electrons. So 8, how many number of electron? 8 electrons, and M shell will occupy how many electrons? Remaining 8 plus 2, that is 10, and total number of electron, that is 19 in case of neutral potassium atom. So how many electrons is remaining? That is 8 plus 2, 10, and total number of electron, that is 19. That means 19 minus 10, that is 9 electron. So according to the rules and according to the Bohr-Berry schemes, so M shell occupy the number of electron is 18. So that should be the third shell will occupy the remaining electron, that is 9, because we have know that the third election can maximum 18 electron, but it is not true. Sometimes what happen in the second rule, that outermost shell cannot have the more than 8 electron, and the shell next it cannot have the more than 18 electron. That means, so these things, that is the 8 electrons, we know that from octet rule. Octet is very stable. Okay, 8 electron is very stable. So according to this octet rule, basically it will come. So the 8 electrons means the last shell, when the third shell, yes, it can occupy the 18 shell, but the rules also said that if the electrons can occupy the 18 rules, that time also the electrons will occupy only the 8 electrons. Okay, this is the second rule. And the third rule, it is not necessary for a given shell to complete itself before another shell will start forming. As a rule, a new shell is formed as soon as the cell attains the 8 electrons. Okay, so new shell whenever the formed, so as soon as the shell that is attains the 8 electrons, so whenever the 8 electrons will come, that means the new shell is one shell is complete, the another shell will start. Like the potassium, means 2, 8, 8. Okay, so 8, 2, that is 10, and again 18. So one shell will complete, finished, and another shell will come, that is the remaining electron, that is 1. So this way. Okay, so and the fourth rule, that is an atoms become the stable, it stops reacting to other elements when its outermost shell has 8 electron, or it has only the one shell containing the 2 electron. So that actually the thing actually come from the octet and the duplet rule. In case of hydrogen and helium, that will be the 2 electrons, and in case of the other, that time it will be the 8 electrons. So the basic rules that of the 2n square rule, whenever write the electronic configuration up to 20 elements up to calcium, that time you have to use these rules in all the time. You have to keep in your mind that the third shell, that is in case of potassium and calcium, this only the exceptional case. In this particular case, the electrons can occupy the 18 electron, we know that from the rules, but In case of 18 electron, that time also the 8 electron only you have to write. Like potassium 2, 8, 8, 1. In case of calcium, that will be 2, 8, 8. Again, it can occupy the more than in 10 more than the 8 more than the 8 electron, that is 10. But the rule said that if the electron is more than the 8 electron, that time you also fill the only the 8 only. And after finishing that or particular orbit, and again the new orbit will start, again the remaining electron you have to fill. So like for calcium, it will be the electronic configuration of calcium, that is 2, 8, 8, 2. Okay, so this is all about your electronic configuration, how to draw the electronic configuration. So this video I have said about only the electronic configuration, and next part I will talk about the next remaining part. Thank you.